All right, let's jump right in. At CES 2026, NVIDIA did something, well, pretty huge. They didn't just announce a new chip, they basically unveiled a whole new roadmap for the future of AI. So today, we're going to unpack that massive announcement, the Vera Rubin platform.
So to really get why NVIDIA built this absolute beast of a system, you have to start with the problem they're trying to solve. And their CEO, Jensen Huang, just nailed it with this one sentence. As AI models get smarter, the sheer amount of information they need to remember, the context is just exploding. And this isn't some far-off future problem. It's happening right now. It's basically the biggest roadblock for the next generation of AI.
So, NVIDIA's Shockwave, the Vera Rubin platform. And yeah, that's their answer to this whole bottleneck problem. It's called the Vera Rubin platform, and the name is actually pretty cool. It's named after Vera Rubin, the astronomer whose work basically gave us the theory of dark matter, this invisible but incredibly powerful force. And honestly, that's a perfect name, because this whole platform is built to power a new kind of AI, one that understands the unseen laws of our physical world. And I really want to stress this. This isn't just about one shiny new GPU. Vera Rubin is a complete top-to-bottom system redesign. We're talking about 6 brand new, super specialized chips. Each one is a monster, for sure, but they were all designed from the very beginning to work together perfectly. It's a total system approach, and that's the key. Okay, a 6-chip revolution, unpacking the hardware. So let's get our hands dirty and dive into the heart of this thing. We're going to break down the hardware, chip by chip, and really see what makes this platform tick. Let's start with the silicon itself. And of course, the star of the show, you guessed it, it's the GPU. Everyone, meet Rubin. This is the direct successor to the already legendary Blackwell chip. This right here is the new engine for AI, built specifically for the absolutely insane demands of training and running the models of tomorrow. So let's just look at the numbers here. Comparing it to Blackwell, Rubin gives you 5 times the inference performance. It's 3.5 times faster for training, and it's got nearly 3 times the memory bandwidth, thanks to the new HBM4 standard. I mean, look, these aren't small year-over-year bumps. These are massive generational leaps. It's just wild. So how did they pull that off? Well, check this out. 336 billion transistors. Just let that number sink in for a second. That mind-boggling complexity is what translates directly into the raw horsepower needed for this next wave of AI. But a GPU like Rubin can't do it all alone. It's part of a team, and its partner is the new brain of the whole operation, the Vera CPU. And no, this is not some off-the-shelf processor they just bought. It's a custom-built powerhouse with 88 of NVIDIA's own Olympus cores. Its whole job is to just feed those hungry GPUs with data faster than ever before. Now, the really critical upgrade here, it's all about the memory. The Vera CPU architecture supports 3 times more system memory than the last one, Grace. And this is so important. Why? Because bigger AI models need way more memory. This chip is built from the ground up to handle that context we talked about, but on a scale we've just never seen before. And again, the scale is just staggering. 227 billion transistors. Just think about that. This is the CPU, the supporting chip for the GPU. The level of complexity across this entire system, it's just on another planet. Okay, so you've got the GPU and the CPU, but how do you get them to talk to each other and to thousands of their friends? Well, that's where the rest of the supporting cast comes in. This whole suite of networking chips. Think of it like the system's central nervous system. You've got stuff like the NLink 6 for super-fast communication inside the box, and then other chips that connect thousands of these systems together into one giant, seamless AI factory. The whole point is to make sure there are 0 bottlenecks anywhere. More than silicon, the open model ecosystem. All right, so the hardware is, well, it's absolutely mind-blowing. But NVIDIA knows a secret that's as old as computing itself. The most powerful silicon in the world is just a paperweight without the software to make it sing. So let's talk about the other, equally important half of this announcement, the open model ecosystem. See, NVIDIA isn't just selling you the car parts. They're giving you a bunch of high-performance engines to start with. They're providing this whole stack of pre-trained foundational AI models. You've got Clara for biomedical AI, Groot for robotics, and a bunch of others. The idea is to create this open ecosystem where developers don't have to start from scratch. They can take these incredibly powerful base models and then build their own specialized apps on top. It's all about accelerating innovation for everybody. The grand vision, the era of physical AI. Okay, so at this point, you have to be asking, why, right? Why build all this insane hardware? Why create this huge software ecosystem?
The answer comes down to one single, incredibly ambitious goal: to kickstart the era of what NVIDIA is calling physical AI.
And that, naturally, leads us to the billion-dollar question. What in the world is physical AI? I know it sounds a little bit like something out of a sci-fi movie, but it's the very real, very concrete future that this entire platform was designed to build.
Okay, so here's the simplest way to think about it. Physical AI is all about teaching AI models the basic laws of physics. It's about getting an AI to a point where it doesn't just recognize a picture of a ball, it understands that if you drop that ball, gravity will pull it down and it will bounce. It's about understanding cause and effect in the real physical world.
And they showed this perfect example in the keynote. With physical AI turned off, you see a simulated robot arm just phase right through a chandelier. You know, like a classic video game glitch. But then they turn physical AI on, and the robot understands the chandelier has mass and weight, so it pushes it aside, realistically. That right there, that's the difference. And this is why it matters so much. Think about it. For a self-driving car to predict that a ball rolling into the street might mean a child is about to run after it, or for a factory robot to handle a fragile object without crushing it, it needs this physical understanding. Physical AI is really the key to making AI not just smarter, but safer in the real world. Solving the next bottleneck, the memory revolution. Okay, but to run these incredibly complex physics-based models of the world, you need a truly astronomical amount of computing power, and crucially, memory. Which brings us right back to where we started, to the problem Jensen Huang talked about, solving that massive memory bottleneck. So here's the core issue. The size of these AI models is growing by a factor of 10 every single year. That is just exponential growth on a scale that's hard to wrap your head around. When you add in the need for longer conversations and way more people using it at once, you've got a full-blown memory crisis, and current systems just can't keep up. So NVIDIA's solution is to completely rethink how memory works. They've built this new tiered system. Think of it like this. Right next to the GPU, you have the absolute fastest memory, the HBM4, for things that need to happen instantly. The next layer out is your standard RAM. Then you have a huge pool of SSDs right there in the server rack. And finally, you have access to network storage across the whole data center. The whole thing is designed to feed the absolutely insatiable appetite of these new AI models. So after all that, when you put all 6 of these new chips together with this revolutionary memory system, what's the end result? Well, you get this. The full NVL72 Rubin system is 5 times faster at inference, 3.5 times faster at training, and has 3 times the system memory of the last generation. From top to bottom, it is a complete revolution in computing. You know, this quote really sums it all up perfectly. And in a way, that's exactly what NVIDIA's whole announcement was about. They showed us the reality, the actual physical hardware that overcomes today's limitations. And then they gave us the understanding, the software and the data that shows us what's going to be possible tomorrow. It's a strategy that grounds a really grand vision in concrete, measurable engineering. And that really leaves us with this final big question to think about. NVIDIA has just built the engine for an AI that can finally start to understand the physical laws of our world. So what happens when we turn that engine on? What new things will we be able to create when AI can predict, interact, and build not just with digital data, but with reality itself? What happens next?